Okay, this is page 3 and 4 of the Unit 7 review. It says answer the following questions and sketch the graph of f of x equals 2x squared minus 3x plus 5. On the graph, label the vertex, the solutions, the y-intercept, and any other point from the table that will fit in the space. Okay, so the easiest and quickest thing to do is do this on the calculator. So we're going to go turn the calculator on, go to y equals. We're going to type in our function 2x squared minus 3x plus 5. Okay, and then we're going to go ahead and go to graph. Take a look at the graph so we know what it looks like. First thing it wants to know is the vertex. So to find the vertex, everything's going to be in your calc menu, so you're going to go second trace, and you have to decide if this is a maximum or minimum. In this case, it is a minimum. So to find vertex, you might want to write that down so you don't forget. So for the vertex, you have to do max or min, okay, depending on the graph. And this is all going to be under the second calc. All right, so we're going to do the minimum. Okay, so minimum. So it says left bound, so I want you to go to the vertex and go left 3 times, press enter. Go back to the vertex, go right 3 times, press enter twice. This will give you the vertex. So 0.75, you want to round to the 2 decimal places, 0.75, comma, 3.875. Okay? All right, and then you want to go ahead and plot those points on your graph here. So 0.75 is in between 0 and 1, and 3.875, so somewhere about right here. Okay, so that's where our vertex is. And again, remember you have the picture here of the parabola. So as you're going through, you can refer back and make sure it makes sense. The solutions, so remember solutions means the x-intercepts. And so in this case, there are no x-intercepts. So just so you're thinking forward, when you have a graph like that, the roots or the solutions are actually imaginary. So there are no x-intercepts. And that's because the solutions are imaginary. Okay, and then the y-intercept. So to get the y-intercept, you're going to go to second calc, and you want to do value. So for the y-intercept, you're going to do value in that second calc menu. So you're going to do value. And the value of x on the y-axis is 0. So you're going to put x equals 0. And then it's going to give you 0, 5. So that is your y-intercept, 0, 5. Okay, so you're going to do x equals 0 when you do the value in that second calc menu. Let's go ahead and plot that, which is right here. Now you need a couple more points to plot that so you can get those from the table. Okay, so you want to pick numbers that are going to show up on your graph here. So we have 1, 4. Okay, 2, 7. Okay, 314 will show up if you go the other way, negative 110, so that's going to be up here. So then you can kind of sketch in your parabola. And again, look back at the graph, make sure that that makes sense. Glare from the light there. Okay, so if we look here, it's not the best drawing, but it's pretty close. Okay, all right, so you're going to do the same thing with the second one. So go into y equals. Remember, if you have a fraction here, you got to do your negative first, and then you can go alpha y equals, enter, which is going to make it look like the fraction as you see it here. So 1 over 2, and then x squared plus 3x plus 2. Okay, once you have that in the calculator, you can go to graph and look at your picture. All right, so the first thing it wants to know is the vertex. All right, so the vertex, again, second trace. When you look, you want to say the minimum or maximum, so this is the maximum at this point. So we know we're going to use the maximum, so second trace. We're going to use maximum, which is number 4. And again, it's going to give you that question, left bound, right bound. So go about to your vertex, go left 3 times, press enter. And then go back to your vertex, go right 3 times, press enter twice. And that will give you your vertex. So 2.9999999 is going to be 3, 6.5. Okay. All right, our solutions, which we know are x-intercepts, so we have a solution right here, solution right here. There's 2 ways for you to do this. The first one, if you go back to that calc menu, second trace, there is one that says zeros. So solutions are the same thing as zeros. All right, so you've got to go to the 0, because you're going to have to do this twice. So notice the cursor is on the about where the x-intercepts is, but it's asking for left bound again. So you go left 3 times, press enter, back up, right 3 times, press enter twice. So that's going to give you 1 of your solutions. So negative 0.6, 0. And we know that we write solutions as x equals negative 0.6, but we do need to graph this, so we need to know our actual coordinate. Okay, and then let's do that again, second calc, and then you go back to 0. This time you need to move all the way over to that other x-intercept. Okay, all right, once you're there, then you do left 3 times, enter, move over, do right 3 times. Once you're back to the vertex, press enter twice. That will give you your other point, which is 6.6, 0. We know the solution is x equals 6.6. Okay, and then before we start graphing our y-intercept, we know that we can find the y-intercept in second trace value. Our value of x on the y-axis is 0, so that's going to give us 2, so 0, 2. Okay, so you can go ahead and plot those points. Remember that you can actually find more points if you go into the table, so second graph, that will give you some more points. Stick with the whole number, so I've got 0, 2, 2, 6, 4, 6. Those will all help you graph the parabola. So go ahead and take a second and graph the parabola. Okay, here's the sketch of my graph. I went ahead and labeled the points. So we had our vertex, y-intercept, and then remember we had 2 zeros there. Okay, so all that you can do in the calculator. All right, next question. Draw the graph of a quadratic function that does not have a solution. Well, we kind of already talked about that. We know that if it doesn't have a solution, that it doesn't cross the x-axis. So the first thing to do is to start and find a vertex. So let's say my vertex is right here. Okay, well, if we look down, we see already that it's asking where the vertex is. So my vertex is at 2, 2. Go ahead, write that down. And then we know the parabola, we don't want it to touch the x-axis because it says there's no solution. So then the graph is going to look like this. And then write the equation of the graph. So the easiest way to write that is in vertex form. So we have f of x equals, and then you have, just like we did on the very first page, your h and your k, and then if there's a reflection over the x-axis, and then a vertical stretch or compression. So this one we know, the only thing we know for sure is that we have the coordinates here, so we know it's x. And we went to the right 2, so insider's lie says -2. It's a quadratic, so we have to put the squared there. And then on the outside we went up 2, so we're going to do plus 2 on the outside. And again, that goes back to our first page when we were doing this. We had our H and our K. Okay, so if you don't know how I did that, I would refer back to this. Okay, so basically you're doing the opposite here. Okay. All right, the next one says draw the graph of the quadratic with the solutions x equals -1, x equals 3. Okay, so solutions, so this one gives you a little different information. We have the solutions here. So it says solutions are x equals -1. So x equals -1, which is right here, and x equals 3. Right? It doesn't give us any other information. It says where's the vertex. Okay, well, we know that it needs to be symmetric on both sides. So we know that the okay, we also know that the parabola is symmetric, which means that I'm going to have a vertex in between these 2 points here. Okay, so parabola is going to look like this. Okay, and then so my vertex here I see is at 1, 4, right? And then to write my equation, f of x equals x, and again, because of insider's lie, -1 squared plus 4. All right, and then the last one says draw the graph of a quadratic function as a domain of -infinity to +infinity and a range of -infinity to -2. I'm sorry, -1. Okay, so I know that my parabola has a domain of -infinity to +infinity, and then it's going from -infinity and it's stopping at -1. So it's stopping right here at -1. And I know that because the range is from -infinity to -1, that this graph has got to turn down for that range to be correct. It couldn't turn up because it's not going to +infinity. Okay, and then write the equation of the function of the graph. So our vertex we see here is going to be at 0, -1. And then our equation f of x equals, okay, in this case we didn't shift left or right, so f of x equals x squared, and then we moved down 1, so -1. Okay. All right, so let's go on to the next page. All right, this one says simplify each expression. In other words, there should be no negative sign inside the square root, and there should be no exponent on an I. Okay, so let's go ahead and take a look here. Right, the first thing you should do for these is to take out the I. So you know when you have a square root of a negative number, then you know that you have to take out the I first, because the square root of -1 equals I. All right, so that's the first thing I'm going to do. Then I have the square root of 80. Okay, you should always check to see if it's a perfect square, because if it's a perfect square, it makes it much more simpler. If it is not, then you have to do a factor tree. Okay, so we were looking for factors of 80. If you don't know factors of 80, the calculator will do that for you by doing 80 divided by x. Go to your table, and these are all factors of 80. So you're looking for factors of 80. I always like to look for the perfect squares because that makes it a lot simpler. See how 5 and 16, and you know 16 is a perfect square. So that's where I'm going to start. You could start somewhere different. 5 and 16, 4 and 4, 2. So I'm going to keep factoring. Remember, because this is square root, I'm looking for pairs. So I have my pairs there. So out there with that I have 2 times 2 times I. And then that 5 remains on the inside. So 2 times 2 is 4, so I have 4i square root 5. Okay? Let's look at the next one. First step again, I have that negative under the square root. So I'm going to take that out, I square root 24. Okay? So I'm going to find factors of 24 because I need to simplify this. I do not want decimals here. I want you to simplify it. So 24. Again, there's more than, a couple factors, so you need to, everybody's going to look different. You'll still end up with the same result. So I'm going to choose 8 and 3. Then I have 2 and 4, and 2 and 2. Again, I'm looking for pairs, so I have 2 here. Notice that the 2 and the 5 I can't do anything with. So they have to stay on the inside and they get multiplied back together. So I'm going to end up with 2 on the outside times I, square root, and then the 2 and the 3. So 2 times 3 stays on the inside. Final simplifying, 2 times I is just 2I, square root, 2 times 3 is 6. Okay, this one doesn't have a square root, but we have I to the 18th. The calculator will do this for you. Okay, so if you go out and you go to Math, over to Num, and then iPart. Okay, iPart. And then we have 12. I is right here where the decimal is, so you have to do second I, the decimal. To the power of, which is the little caret, and this one's 18. Arrow out, close the parenthesis, press enter. Negative 12 is your answer. Okay, then we have the next one, same thing, Math, Num, iPart, 5I to the power of 63, close parentheses, so negative 5I. And then the last one, oops. Okay, again, that's second Math, Num. Number 3 is iPart. Okay, all right, so, but for these, when we have the square root, we need to simplify first. So we know that the square root of negative is I, but then the square root of 16 is 4. So I have 4I over here times square root of negative 25. So the square root of the negative is the I. Square root of 25 is 5. So I have 4I times 5I. 4 times 5 is 20. And then I times I is I squared. Okay. And then if you put that into your calculator, I squared is negative 1. So I have 20 times negative 1, which is negative 20. Okay. Again, if you don't know your perfect squares, you could check in the calculator second, and right above the x squared is the square root sign. So 16, which gave me that 4. Okay. You should be familiar. Remember that there's cycles of I. So up here I wrote that the square root of negative 1 is I. And then you have I squared, which we just saw was negative 1. And then I cubed, so second I to the power of 3 is going to be negative I. And then I to the power of 4, which is going to be just 1. But you should be familiar with those because they just cycle around, okay? Then you're going to go back to I to the 5th is going to be I, or the square root of 1. I to the 6th is going to be negative 1. So it kind of goes in a circle pattern, and then it keeps cycling through these answers. Okay, but the calculator does do it for you as long as you know what buttons to push. Okay, simplifying. The calculator will do this for you. You just need to be in A plus BI mode. So let's go ahead and make sure that everybody, if you have a calculator at home, you're in A plus BI mode. So that's going to be second mode. I'm sorry, not second, just mode. Down here, see where it says real? So we want to go to A plus BI. Again, that was in the mode menu. Move that up a little bit. Right here in the mode menu. Okay, scroll down. Real, we want to do A plus BI, enter. And then we're going to quit out of there. All of these can be entered. You can do these by hand, but they can be entered directly into your calculator. Okay. All right, so the first one is 4, and enter it just as you see it. So we have parentheses, 4 minus I, close parentheses, minus 6 plus 7I. Close parentheses, press enter. So negative 2 minus 8I. That's it. This part's the real part, and then the part with the I is called the imaginary part. So this is the real part, and this is the imaginary part. And you always write them in that order. Okay, let's do the next one. Parentheses, 3 plus 2I, close parentheses, plus negative 7 minus 3I, close parentheses, enter. So negative 4 minus I. Okay. Four plus 6I. 5 minus I. Oops, sorry about that. 5 minus I. And this is multiplication, but it still will give you the correct answer. So 26 plus 26I. And then the last one, 3 minus 4I. 2 minus 6I. Close parentheses. Negative 18 minus 26I. That's all you have to do for these. So as long as you know where the I is and you know how to turn that function on mode on your calculator, then you're fine. Okay, the next one is, which of the following is equivalent to 5? All right, so this goes back to what we were talking about here about the real part and the imaginary part. So you always have a real part, okay? And 5 is going to be your real part. And then the imaginary part, if there's no imaginary part, then that means it's 0. So if you look through here, you know that the real part is 5, which pretty much just eliminates all your choices except B, because it's always going to be A plus BI, A being your real part, so that's where our 5 is, and then BI being our imaginary part. Even though there's not an imaginary part of this problem, see, it's a 0 times I, which is just 0, which is going to leave you with just 5. Okay? All right, so let's look at the next one. We have, which of the following is equivalent? This time we have an imaginary part, so we have a minus 3I. So there's no real part, which means that real part has to be 0. Okay, so 0 minus 3I, and we always write it in this order with the real and then the imaginary part. So 0 minus 3I, which C is going to be our answer there. Keep going, same thing. This time, real imaginary, we have 0 plus 6I. Okay, because there's no negative in front of there, so it's going to be positive. And then here, we have negative 7. This time we don't have our imaginary part, so plus our BI. Our B is going to be 0I. So negative 7 plus 0I. All right, let's keep going. So the solution of the quadratic equation is negative 4 minus 5I square root 7, which of the following is also a solution. Okay, we know that when we take the square root of something, it's always going to be plus or minus that number. So for example, if I have the square root of 4, this is a very simplistic example, square root of 4, then I know that it's plus or minus 2. So when we use our quadratic formula, we have negative 4 minus 5I square root 7, which means I have to have negative 4 plus 5I square root 7. So that's going to be our D as our choice there. Okay, and then the last part says that circle all that are equivalent expressions. Okay, equivalent expressions means it's going to come up with the same answer. So these are kind of tricky because in the calculator, it's going to be difficult to just put all of these in. So this is my suggestion for a problem like this. This is to isolate the I. Notice that the I has every every problem has an I in it, okay? Because if we simplified this, the square root of negative 144, we would get 12I, okay? But there could be other expressions that still represent that 12I. So let's take a look. We know they all have I, because we know the square root of negative 1 is I. So I have 12 square root 12, okay? Well, does 12 square root 12 equal 12? No, that's going to be, so 12 square root 12 is 41. So we know that that one doesn't work. We already said that one worked. So this one is I square root 144. So let's look at this. Remember, the I is the same for all of these, so that's not my concern. My concern is this 12, okay? So the square root of 144, I know is 12. So this one would reduce to 12I as well. So we know that this one works as well. Okay? 2 times I square root of 36. So let's leave the I on the outside here. 2 square root 36. So 2 square root 36 is 12 as well. And we know that the square root of 36 is 6, so that would have given me I 2 times 6, which is 12I. So we know that one works as well. So again, we're looking for 12I in each of these. If it doesn't work out to be 12I, then it's not equivalent. It's not the same expression. Okay, let's keep going. So the square root of 72, so essentially the I, we're going to just leave alone on the outside because, again, it's the same. So 2 times the square root of 72. 2 times the square root of 72. It's giving me 16.9, so that one doesn't work. And then the last one, again, we have our I out here, 6 square root 4. 6 square root 4. It's going to be 12, so that's 12I. We know that works. If you had done it by hand, square root of 4 is 2, so then I would have had I times 6 times 2, which is going to give me 12I as well. So all of those work out. And that's it for this video.